This webinar will begin with a brief overview of the chemistry of the phase, as well as the underlying zirconia particle. It will continue with some guidelines for use. The webinar will conclude by highlighting 3 of our most popular ZirChrom PBD applications. All ZirChrom phases are based on a zirconia particle. The crystalline structure of the zirconia particle has 7 bond valency when compared to silica's 4. The additional bonds in the crystalline structure of zirconia protect the structure from hydrolysis. The result of this unique configuration is a particle with superior stability and a unique surface chemistry. The surface chemistry of zirconia has 3 types of sites, all highly reproducible and homogeneous. There are Bronsted acid sites, Bronsted base sites, and a large population of Lewis acid sites on the surface of zirconia. For further information about the unique surface chemistry of zirconia, please click on the Technology Overview ChromeU webinar link that can be found on the ChromeU page of the ZirChrom website. The ZirChrom PBD phase builds on the zirconia porous particle, coating it with polybutadiene, which is then cross-linked. This creates a cage-like phase in and around the zirconia particle. Using a ZirChrom PBD column adds a wider array of tools to your method development toolbox. The ZirChrom PBD phase is both thermally and chemically stable. It is stable at temperatures of up to 150 degrees Celsius throughout the entire pH range and is compatible with a wide array of organic solvents. The unique surface chemistry of the ZirChrom PBD phase allows for multimodal selectivity for ionic compounds. For non-electrolytes, the selectivity of the ZirChrom PBD phase is the closest of any zirconia phase to that of the typical silica C18 column. However, it is slightly less retentive, and we recommend starting with about 10% less organic modifier. Here are some great examples of how the unique selectivity and unparalleled stability of the ZirChrom PBD phase can be put to use. One of the most popular applications for the ZirChrom PBD column is amine-containing compounds. Using traditional silica C18 columns, these basic analytes often fall prey to peak shape and selectivity issues. Technical Bulletin 174 shows 2 separations of a set of positively charged pharmaceuticals using identical conditions, first on the ZirChrom PBD column, then on end-capped silica C18. The multi-mode retention of the ZirChrom PBD column not only offers improved peak shape for the compounds, but also an alternate selectivity. ZirChrom PBD has the USP designation L49 and is the column of choice for the analysis of azithromycin. Technical Bulletin 239 is a great starting point for users that wish to analyze azithromycin or compounds of a similar structure. The thermal stability of ZirChrom phases allows for the routine use of elevated temperature without sacrificing column lifetime. Increasing the method temperature reduces the mobile phase viscosity, allowing for increased flow rate and thus decreased cycle time. Technical Bulletin 292 details a real-world example of how a ZirChrom customer reduces their cycle time from 30 minutes to 10 minutes with only a modest increase in temperature using equipment they already had in their lab. Please note that all presented application notes are available at any time on the ZirChrom website at www.zirchrom.com. Thank you for completing this ChromeU webinar. On the ZirChrom website, you can access our full ChromeU webinar series, use our free Buffer Wizard tool, or learn more about ZirChrom products and applications.